Hello, everyone. Thank you for joining us for another live webinar session hosted by EE Tech and All About Circuits. My name is Dale Wilson, and I'll be your moderator. Today's session is brought to you by Omron and is titled Heat Pump and Flammable Refrigerant Application Solutions Using Explosion-Proof Relays. Let me tell you about our presenter. Zach Hendricks has a Bachelor of Science degree in Mechanical Engineering from Northern Illinois University with an emphasis in sustainable energy. He is currently the Relay Product Manager for Omron, serving as the America's technical contact for Omron's diverse relay product offerings. He has expertise with relay applications within the automated test equipment, factory automation, and smart home building industries. During today's presentation, we will post several poll questions to gather insights and feedback from all of you in our audience. So keep an eye out for those, as we would love to hear from you. Following the presentation, we'll have a live Q&A session. For the Q&A, Zach will be joined by his colleague, Jim Neville. You can submit your questions at any time during the webinar using the chat box on the right-hand side of your screen. We will also provide attendees with a downloadable copy of the presentation near the end of today's session. This will be available in the Resources tab, along with a few other helpful documents that you can access at any point during today's presentation. Thank you so much for joining us, and with that, I'll hand it off to Zach to begin today's presentation. Welcome, Zach.
Thank you very much, Dale, and thank you everyone for joining. Today, I'm going to be talking about Omron's drive to provide anti-explosion relays, explosion-proof relays for heat pump and flammable refrigerant applications. So before we get into the content, I'd like to talk about Omron Device and Module Solutions Company and what we have to offer. Omron Device and Module Solutions offers components to the industries. We have sensors and modules, which makes up about 20% of our business. We have 6% being connectors, which one of those I'll talk about here today. 24% are switches, ranging from tactile to trigger switches to general purpose basic switches. And the bulk of our product is relays, which is what my focus will be on today, the explosion-proof relays for green refrigerant applications. But as you can see, in the 50% of that puzzle, we have general purpose relays, DIN rail mounted relays, socket relays, MOSFET solid state relays, automotive products for small mobility and built-in automotive. And we also have high power AC and DC relays. Again, today's focus will be the explosion-proof relays, which are all PCB-based solutions. Now, let's talk about Omron's drive for positive social contribution, which leads us into this webinar. Why are we here today? Why are we talking about refrigerant use? So Omron has set the goal of addressing 3 major social issues that impact society, where we can leverage our strength for device and modules into those types of solutions and industries. Those social issues that we're addressing are achieving carbon neutrality, realizing a digital society, and extending healthy life expectancy. So the big focus for today is that achieving carbon neutrality over here on the left. And we do that in a lot of different ways. And what it means is we want to lower the net carbon that's released in the atmosphere. We want to help the environment, right? The industries that do that are industries like energy, where we're looking to move towards solar power devices, moving to solar power generation, energy storage, electric vehicles, electric vehicle charging. We're developing components to fit those industry needs. We're also reducing the power consumption of our components, like low power consumption coil relays, to lower the amount of electricity needed to power our devices. And most importantly, for why we're here today, is we're looking to contribute to reducing the releasing of toxic gas and high carbon gases into the atmosphere by supporting the movement to greener refrigerants by developing explosion-proof relays. But before we get into those relays and the background behind that transition, that movement, we're going to pop up our first poll question here. And it's essentially asking you what application or industry best describes your interest in today's webinar. So if you could please answer that, we'll have 3 more throughout this presentation. And thank you very much for your responses. So to support the global trend of semi-flammable refrigerants, we look at the macro trends that exist. We have the Montreal Protocol, the Kyoto Protocol, Paris Agreement, Kigali Agreement. All of these are relating to climate change protection and mandating certain gases and refrigerants that can be used to better the environment. And that refrigerant trend is reducing the ozone depletion potential limit that we are allowing in these such refrigerants. So we're moving to a safer refrigerant for the environment. And it also lowers the global warming potential, which is GWP. Now, when we're reducing these levels, both ODP and GWP, we're moving towards a more flammable refrigerant use in these types of applications. So when you have a more flammable gas, you have to be considerate of ignition sources in your application. And one of those ignition sources can be relays. So the need is evolving in different industries for explosion-proof relays to relate with these semi-flammable, eco-friendly gases. And when we're talking about low GWP refrigerant use, we're talking about moving from high GWP levels like the R410A and R32, which are lower flammability levels, the A1 flammability, and A2L, which is semi-flammable. We're moving to lower GWP levels than that. So everything that's circled in the dotted red box. So we have a double-digit and single-digit level of GWP and a higher pollution and flammability level. So we're lowering ozone depletion, we're lowering global warming potential, but we're having to deal with the semi-flammability. What does that have to do with relays? That has to do with the ignition source that relays add to the equation. So being an ignition source, because they have some arcing that can occur between the distances of the contacts when they're breaking or making in operation. There can be some arcing where that electric current will jump from one contact to another contact, which can ignite the combination of a green refrigerant, which is semi-flammable, and with the air and cause an explosion. So we need there to be a safe option for this transition to these types of refrigerants. And to ensure that safety, we look at relays in two categories. So relays switching 16 amps or less and relays switching more than 16 amps. When we're talking about 16 amps or less, to gain that explosion-proof certification, we need to verify that relay does not explode in accordance with IEC testing. So that's typically opening and closing the contacts 10 times in a flammable gas environment. And when we're talking about switching in 16 amps or less, this means that we don't need a sealed relay. It can be a relay that allows some gas within the internal components of the relay, as long as they do not ignite. But when we're looking at 16 amps or more here on the bottom, we do have to deal with a sealed type relay. So to gain that explosion-proof certification, a sealed type is required. That relay must be in accordance with that IEC evaluation and must have an air tightness test. So completely sealed, gases cannot get within it, and that arcing will never have, it will always have isolation from the external environment. This is where a lot of the ground is untapped for relays, which are considered the ignition source. So we are looking to expand in both regions, but primarily for new product in the 16 amp, more than 16 amp sealed relay category. So let's look at Omron's explosion-proof lineup. On the left here, we have the protection structure, which we notate as sealed or unsealed. So unsealed type versus plastic sealed type. I'll talk more about what those protection structures mean on the next slide. But for unsealed type relays, we're looking at our platform products here in the middle. So G5NB, G5Q, and G2RL, we have certifications for all three of these product families, and we call them our platform products because they're well-known footprints in the market. They're widely used across various industries, including home appliance and HVAC, and they're the grounds for most of our expansion in terms of new relay products. So we offer both sealed and unsealed types of these products, all with explosion-proof ratings. Once we get past the 16 amp marker, we're now looking into that untapped territory I was mentioning. So one of the existing platform products can reach 16 amps and above. So that is one of the options for above 16 amps. We also have a newly released G5PZ, which I will talk about in a few slides. This is a sealed product for 20 amp switching. And then we will be coming soon in the next year, we will be releasing a G6QE sealed version. So this is a 30 amp and 36 amp product that can reach even higher loads for compressors and motors in various applications that need this sealed explosion-proof rating. So what are the differentiations between the relay protection structures as according to Omron? So we're looking at the enclosures here on the left. We call them flux protected type, which are unsealed type, but protect against flux and dust. And we also have the sealed type below that. So first, for flux protected, it protects against dust from getting within the relay and causing any issues with the contacts or contact resistance change. These relays are not fully sealed again, so they cannot be washed or coated. It has some protection against dust, but it is unprotected against gas. Now, what's good about these relays, why it's good to look at unsealed, is if you need a longer electrical life, these relays will potentially have a longer electrical life than a sealed relay. And that's because you're allowing that hot air from inside the relay to escape through whatever break in the seal there is. When we look at a sealed relay here at the bottom, this structure completely prevents the penetration of flux during soldering and solvent during cleaning. So it is washable and it is applicable for coating. Now, what's also great about it is it prevents from dust getting in the relay as well as from gas. And this allows for it to be used in an explosive gas environment, a semi-flammable gas environment, right? It has no interaction with that outside gas. It cannot ignite due to arcing within the relay. The only issue that we may see with the electrical life on a sealed relay is it will be a little bit shortened as compared to an unsealed product because it will be holding all that heat within the casing. It doesn't have that ability to remove the hot gas from within. So we just have to consider that and look at the electrical life ratings for each product. Now, what is the value of explosion-proof relays for those of you that are using semi-flammable refrigerants or semi-flammable gases in general in your applications? Well, it contributes to the cost reduction since that relay itself is an explosion-proof product. It is no longer an ignition source. It is a space and cost reduction. If you look to the from box here, we typically would have to protect using a metal or other type of housing all of the elements that are at risk for ignition in an application with a flammable gas. Or you would have to have some isolation between the switching or ignition components and the product itself. With these relays being intrinsically anti-ignition sources or explosion-proof sources, you can move to a component level conformation. That means you do not have to have that additional bill of material item, the metal housing, and you can save space and you don't have to worry about isolating the product anymore. What are the safety standard conformations that are revolving around these explosion-proof relays? For our products, we have certified under different IEC ratings. Firstly, we've developed a lot of these products already with home appliance ratings for flammability, so lower flammability casings, IEC 60335-1. We've adopted and certified under IEC 60335-2-40, which is specifically calling out air conditioning and heat pump applications. And this is already moving towards component level elimination of them being a source of ignition. And now we have added the explosion-proof standard to these products of IEC 60079-15 for use in explosive atmospheres. So we want to see what products Omron has to offer out of all of our series. And this is just a limited view of what there is already out there. This is from existing products, and these are the 3 platform relays that I talked about previously. So I'll go through these. I'll talk about what is the same amongst all of these series and what value each series has to offer. Just to start over here on the right, we could see firstly that all of these conform to the IEC-EN 60079-15. That's the explosion-proof rating. All of them also are conformed to the glow wire standard for anti-flammability in home appliance applications, and then a spattering of different safety standards further on the right columns. This will be for your reference since you'll have this presentation after the webinar. And then let's look at the relay models. We do not have all of the models listed on this slide. That would take up a lot of space. We wouldn't be able to see anything, but this is looking at some of the major models to consider. So all three of the product families, G5NB, G5Q, and G2RL, have both sealed and unsealed models, even though we're looking at below 16 amps and at 16 amps. So if you need a sealed version, we still have the options available below that marking. We have various contact forms, and we have various contact rates. For G5NB, we have one form A contact form only. We have 5 to 7 amp support. For G5Q, we have one form A and one form C contact forms, and we support 10 amps on the normally open contact, and for one form C, 3 amps on the normally closed. Now, lastly, we also have high inrush models for motor loads. So high inrush of 30 amps, one form A switching. And I'll talk about this product in a little bit more detail later on. The last platform product we have here is the G2RL, which is a 16 amp relay as the high capacity version. And it will also come as one form A and one form C, supporting up to 16 amps. Last thing I want to note on this slide is the class coil for all of these products is class F, and the ambient operating temperature is from -40 to 85 degrees Celsius, though we're looking to expand to models with higher temperature thresholds further down the line. So let's look at these product families individually. First, the G5NB, which is the smallest relay of the three we've talked about. Looking at the specification going down the list 1 through 6, it's a miniature one form A power relay, so just an open closed relay. It has a high switching capability of 7 amps 250 VAC and 5 amps 30 VDC. All of these platform relays and our products moving forward will focus on having low power consumption coils. So a high sensitivity coil with 200 milliwatts power consumption, 10 kilovolt impulse withstand voltage, so strong insulation. All models or all types with specific models will be conformed to that IEC rating we're talking about for explosion proof. And our general applications are widely varied. So I have all of these products highlighted in yellow here and underlined because all of these products have models available for the anti-explosion rating, ranging from 3 amps at a very high 200,000 cycle range, all the way up to the 5 amp and 7 amp models for 200,000 and 50,000 operations respectively. So long lifetime, a lot of support, and a lot of great value. Secondly is a little bit bigger. It's the G5Q, and this is moving into higher current ranges. It comes in both one form A and one form C contact forms. It is a high switching capacity of 10 amps in that package with a 200 milliwatt coil again, 8,000 volts impulse withstand, and conformed based on the standard and EL3 types of G5Q, but likely to expand into more models as we move forward in time. Now down here, again, I've highlighted in yellow what products are available for this explosion rating, anti-explosion rating. The G5Q standard is one form A or transfer contact one form C, so switching between modes. We have high endurance for the different ratings in the standard product. And then let's look over here on the right. This is for those motor load applications, the G5Q EL3. So it only comes in one form A open closed relay, but it offers a high 300,000 operation motor load rating for a 30 amp inrush with a 3 amp break at 250 VAC. So for those motor applications around 10 amps, this is the product we look for. Next is the G2RL relay, the biggest and the most robust of the three platform products. As we could see here, the amount of types is a lot more various than what we saw on the previous two. It's low profile of 15.7 millimeters. It ranges from 12 to 16 to 23 amps, though the 23 amp version is not yet rated with the anti-explosion rating. Our 16 amp is our cap here, but expect that to improve. High insulation distances, 8 millimeters, 10,000 volts impulse withstand. high temperature types, 105C, not yet available as explosion proof in the 105C variety, but down the line it will be. It's already planned. And we also have the standard and E-type that are conformed to the IEC 6007915. So this includes a single pull, one form A and one form C option, and also a dual pull, two form A and two form C option for 12 amps, and then a one form A and one form C option up to 16 amps in the -E high capacity version. So that's existing products. There's a lot of part numbers, there's a lot of models in those three families alone that are existing and have that certification. So if you have interest in that 5 to 16 amp range, please contact an Omron representative, contact me, we'll talk about it, we'll find a product that fits your needs. But in terms of new product development and what we already have new, that's where we're looking to this page. So our new products are going to be focused on our target industries. And for high current, so 30 amps and above, our major focus, and this is based on those social issues I talked about earlier, is the energy industry. So solar power inverters, energy storage, uninterruptible power supplies, EV charging. These are all very high current, high voltage applications. And we're looking to displace contactors with very high level PCB relays that bring everything board-based and don't rely on manual assembly of contactors. So that's with our release of G70BE, 120 amps, 800 VAC, and the highest PCB power relay on the market today, which is the G9KAE, which is 300 amps at 1000 volts AC. So these are single pole, single throw relays that we're looking to improve upon to meet the needs of these high voltage, high power applications. Next, and the focus for today, is the home appliance and building automation sectors, primarily HVAC in this case, a wide variety in variation and capacity increase amongst our existing products. So what we're looking at here is the G5Q, which is that platform relay, the secondary platform relay, which we've expanded into a high current, high inrush, and explosion-proof model within the same package. This is what you'll keep seeing with our existing products, is we're looking to meet market needs without sacrificing board space and sticking with the products and the product sizing and footprints that we've come to know and love, right? And then lastly, ATE, which is automated test equipment. We continuously release new MOSFETs over time that meet different characteristics needed by the low signal loads of test and measurement switching. So potential future conformed IEC explosion-proof relays. This is where we're going to focus for the future. These are what we already have considered for development or we're already releasing. This ranges from 5 amps all the way down or all the way up to 30 amps for various applications in the explosion-proof sector, right? Starting with the G60N, this is a small one-form A relay that will be sealed. We'll add, and it's also a high temperature variety, so 90 degrees Celsius. This will be added in the future. G6RNE, the secondary product on this list, is something that we've already planned to release. It will be coming out next month. I'll talk more about it in a couple of slides. And then we look to build upon that for an even higher capacity sealed version with the G6RNEL. The G2RL-CV is a high 105 degrees Celsius model of our G2RL platform relay. So expect that we're going to improve the operating temperature range of these products for anti-explosion. And then the last two on this list are both newly released and upcoming products. So the G5PZ and the G6QE. The G5PZ is newly released as of last year. It is a 20 amp relay, so expanding beyond the 16 amp, getting into that sealed territory. And then the G6QE is looking to reach contact currents of up to 30 amps and 36 amps for certain ratings. So much higher, but still a small PCB relay for general HVAC use. So let's look at the three products that are most nearing release. This one is already released. It's the G5PZ1A4. It's a sealed relay. It is a compact and high current product, so 20 amp switching with slim size, so 10.5 millimeter width, 24 millimeters in length. So it contributes to downsizing of high capacity equipment. It allows for highly dense boards to be developed, side-by-side relays. It saves in energy because it is a 530 milliwatt coil in a 20 amp class of relays, which is relatively low. And then, of course, it is conformed to the IEC rating for explosion proof. So the main things to note about this relay is that it is sealed. It is 1form-A for open-close switching. It has 20,000 operations at that 20 amp 250 VAC. It has inverter load ratings as well for 50,000 operations, 250 V, high inrush of 240 amps with a make and break current of 0 amps. So if that is of a necessity to you, it has safety standards existing and then the improvement of the anti-explosion rating. And lastly, it is important to note that there will also be a 277 VAC rating for 6,000 cycles. So this product is already released and available if you have a 20 amp need. The coming soon relay, we should be releasing this within the next month. It is the G6RNE, so a high capacity version of the existing G6RN series. It will have an improved rated load current from 8 amp to 10 amp. It will have new safety certifications achieved. So it's adding that home appliance rating for flammability, the 60335-1, and of course, the explosion proof rating of 0079-15. And it will also have high dielectric strength in a small package, so 6,000 volts AC. This will also be for your reference. You can look at it to compare to the existing G6RN. So this is the high capacity version adding the E, and then the G6RL, which is a very similar product. We're matching that capacity as well at a higher dielectric voltage of 6,000 volts. So very long lifetime for these products, 100,000 operations, 10 amps. It's 1form-A and 1form-C. So 10 amp, 100,000 cycle for the normally open contact, and 8 amp, 100,000 cycles at 250 VAC for the normally closed option. And the last upcoming product that is confirmed is the G6QE1A4. And that 4 here is indicating a sealed type product. So this is sealing of an existing product, just like we did for the G5PZ, offering different ratings, but offering that explosion proof capability. So 36 amp at 480 VAC in a very small package is what this product has to offer. It has energy savings in that you can apply a holding voltage to the coil. So once you empower that coil with the full rated coil voltage, you can drop that back to 35% of the rating and still keep the contacts engaged, greatly reducing the power consumption of the relay while it is activated. This product, again, will be plastic sealed. It is a 1form-A relay. And then our ratings are really tailored to inverter type loads, but we are always open to test for different ratings that are required by our customers. So the general ratings for resistive load will be 20 amp 250 VAC for 1,000 operations and 36 amp 480 VAC for 100 operations. And in terms of the inverter load, which is what we're developing this for, it's 480 VAC, 240 amp inrush, 36 amp steady state, and braking at 0 amp. So braking with no current. That's for 100,000 operations. Now, the most important question is, where can we use these? What functions are we looking to support with the explosion-proof relays, and in what applications? I think the title of this webinar in itself kind of dictates what, or explains what we're looking to support and what we can support with these relays. But this is generally what we're looking at here. So on the left side, residential and commercial cooling and heating equipment. So HVAC, and this is a very broad category, but there's plenty of refrigerant use applications or explosive gas environments that can use anti-explosion. If we're digging a little bit deeper from HVAC, we'll find a couple of key applications that we could target. One being a big focus for Omron, which is heat pumps. Heat pumps is growing globally as a form of heating and cooling, both residentially and commercially for buildings, because it is a highly efficient system that doesn't rely on combustion of carbon-based substances and doesn't rely on releasing corrosive elements or toxic elements into the air. This is our major focus, and I'm going to be talking about the functions within heat pump and how our relays can relate within and how they relate those functions to all of these other applications on this slide. And water heaters also falls into HVAC and is very closely related to heat pumps in that air-to-water heat pumps operate similarly to water heaters on their indoor water heating elements. So I'll talk about that in the next slide too. And then lastly, of course, general refrigeration equipment that uses refrigerants to maintain the cold temperatures to keep their end products cold, right? So all of these applications have similar functions within, and that's what we're going to go over here. So heat pump, this is the example that we're going to use to relate all of this together. And these are the functions that are typically switched within varying applications for relays. Heat pumps are taking the outside air, removing that heat, and utilizing it to help heat water on the internal elements of this air-to-water heat pump. And within the inside unit, we have a water heating device that takes that hot water and radiates it throughout the home. So the reason why we're using this as an example is because these types of functions exist within a lot of varying applications, right? We have compressors, we have valves, we have motors, in this case, the motor fan that's outside. These exist in traditional and modern types of heating and cooling and refrigeration. For a compressor, for 16 to 20 amp switching, here we have listed our products that are most widely used for these types of applications. So G2RL, which is a 16 amp to 23 amp relay, G5PZ, which is a 20 amp sealed relay with explosion proof, and then the coming soon G6QE that supports 20 to 36 amps switching with that sealed explosion proof rating. And then when we're looking at those smaller level loads for valves and motor fans, we see the G5NB, G5Q, G6RNE, which is that upcoming product we talked about. This is supporting 5 amps up to 10 amps, and also with the G5Q supporting those motor load inrushes of up to 30 amps. Now let's go back over to the inside. So once we're on the inside, we have different control loads and signal loads that don't need that explosion proof rating because it's just a typical thermostat or controller that is already isolated from the end product. It's not near those flammable gases. But of course, Omron does offer both switches and relays that support this space. But once we get inside the water tank, we're talking about valves once again. We're talking about heaters. We're talking about motors and pumps, which can all use similar relays. So for valves, once again, we're looking 5 to 10 amps, and that would be the G5NB, G5Q, and G6RNE. And for the higher power items like heaters and motors, we're talking about the G2RL, G5PZ 20 amp sealed relay, and the upcoming G6QE. So the products that we already have support the functions that require switching within the end products like heat pump and traditional HVAC and refrigeration. Another product I want to talk about before I get off the subject of these applications is the XW4M/N terminal block PCB connector. And the reason I bring this up is because HVAC and similar applications, home appliance applications, can utilize this connector for ease of use. This is a quality of life type PCB block connector or terminal block PCB connector. If we look at the upper left, we have the XW4M is the plug of this product, and the XW4N is the corresponding socket to this product. So why this is great for quality of life? They offer various models with pin count options and straight or right angle PCB terminal sockets. If we look here on the lower left, we have a dual spring structure that reduces the insertion and removal force just by depressing that blue lever on the XW4M, the blue lever you can see there. And if you look on the right here, this kind of explains the action that's happening when you're doing so. It allows you to use one hand to just simply remove and insert this product, right? This is due to the spring system, the dual spring system that removes the friction element within the socket. So you're just not relying on the frictional force, you're depressing those springs in order to allow the removal. And then lastly, the additional quality of life is the pin number markings that the connectors have, and they also have release holes, which provides the ease in wire removal by a quick insertion of a slotted screwdriver into the square slots there, the release hole slots. So a great quality of life improvement for these types of connectors, and a lot of models available if you have interest for your application as well. So I've talked about the relay products that we have to offer, the relay products that are coming down the line in the coming year. What explosion-proof offerings we will expand to for this transition in green refrigerant, right? Moving from the non-explosive but higher carbon element refrigerants to those semi-explosion low GWP refrigerants. Now, if you want to find more information, more supplemental information, as well as a list of all the compliant relays for this category, on our website, we have a web page called the Green Project webpage that I have boxed here in red that anybody can visit. You can take a look at what we're doing to contribute to carbon neutrality as a company, and also within that, find what products we have that are green refrigerant compatible. These power relays for IEC EN 60079-15. Please stop by. It's a great resource to supplement what you're learning here today. Now, before I talk about what we have to offer on the web, we also have a final poll question. We would like to know if your company has already made the transition to some semi-flammable refrigerants. We want to see what the timeline looks like for you so we can best support you guys. But you can also find us here. We're located in Hoffman Estates, Illinois, near to Chicago, Illinois. Our website is components.omran.com. That's where you can find that page on the previous slide. And you can also find all of our data sheets and product and company information. And lastly, follow us on social media, LinkedIn, Twitter, YouTube. We have all of our upcoming events, our webinars. We have listed many product videos and industry videos on our YouTube channel. It's a great learning resource to see what's new with us and where our targets are. So please stop by to our social media and our website. And that's it for my content today for this webinar. Thank you very much for your time. I would love to answer some of your questions, so please stick around for Q&A. And with that, I'll hand it back over to Dale to get that started. Thank you.
All right. Thank you, Zach, for that insightful presentation. It was really interesting to me, as you hear a lot about that drive to move to new refrigerants. I mean, even the popular press and the news media will sometimes discuss the topic, but I wasn't aware of the explosion risks and the associated engineering challenges this presents when migrating to these new refrigerants. So again, very interesting to me. So we've got several good questions from our audience, and I'll remind everyone that there's still time to submit your questions. Use that Q&A chat box on the right. So Zach, are you and Jim ready to answer some audience questions?
Yeah, that'd be great. Looking forward to it.
All right. So first one here, I really like this question. It says, you state that the needs are developing or emerging. Are the HVAC OEMs actually requesting explosion-proof relay products, or is Omron attempting to get in front of this and assuming there will be a demand?
That really is a great question, and I don't think I touched on it enough in this presentation. But to start, I mean, Omron, we're a global company, so we have representation in Asia. We have sales there. We have sales in Europe, a great presence there, and we see a lot of these mandates to move to these greener refrigerants originating in those places in the world. And so we already have customers there that, yes, they have those needs or they have requested them, and that has kickstarted a lot of this motion. But when we're moving over to the Americas and talking about the transition here, it's definitely seen to be a future development. There's not the stringent regulations right now on those refrigerants, but I have heard from customers and from people in the industry who have these expectations of moving to these refrigerants. So it's good that we got the head start in other places globally, but we're trying to get ahead of that curve for the Americas for that transition here. So good question.
Yeah, and thank you for that answer. The next question we have here is asking, what is the switching current range for your explosion-proof product offerings?
So for that, we have our lowest rated relay, which is the platform product, the G5NB. That starts our range at the 5 amp level, and our current G5PZ sealed, so G5PZ1A4, that's our highest switching product at 20 amp. That's the NPI that we've released. And then after that, our G6QE will push our range to that 36 amp level when we release it later this year.
Since we're on the topic of currents, I'm going to jump in with my own question here, just to feed off that last one. Why is 16 amps the kind of the magic thing between sealed and unsealed for relays?
So that's also a good question. When the current exceeds 16 amps, the potential for sparking or arcing increases. So that's in accordance with IEC, that's the level in which we start to have that concern. It's probably, we won't see true problems until after maybe at 20 amps, but that factor of safety, we want to give a number to be the threshold to cut off. So we have that full isolation from the semi-flammable gases. So it's really developed by the IEC as that level of dangerous arcing potential.
Oh, okay, that makes sense. So another question here from the audience is, are there any new relays from Omron or only the certified relays that you presented today?
Okay, yeah, of course. Yeah, we have a lot of NPIs, especially for relays, since it's the biggest product within our portfolio at Device Module Solutions. So I mentioned our focus is green energy, and that is also that high power PV inverter, energy storage type devices. We have released the highest power PCB terminal product. That's an NPI, and that's a 300 amp relay at 1000 volts AC. PCB based. And then just also within this month, we have expansion of existing series, a high temperature 5 amp relay, a solid state relay. But if you want to hear about the NPIs, you can visit our website, and our social media activity will really give you insight into what's coming soon or just released.
Okay. A question here, Randy asks, how are you addressing UL approval use with A2L refrigerant under UL 60335-2-40? So very specific.
That is a very specific question. So addressing UL approval, we haven't had the UL ratings for all of our products, but we do have the IEC 60335 for many of these products that I talked about today. This would have to be more digging on our end for supporting the American industry. From a lot of customers that I've talked to about the existing products that we have IEC rated, so rated by European standards, that has been sufficient for the A2L transitioning to those higher pollution and flammability, or lower pollution, higher flammability refrigerants. So I think this is something we have to research a little bit more into, and adding UL certifications when needed by customers. If you have that need, please bring it to us, talk to us directly so we can add new certifications on top of the IEC ratings.
Excellent. Before we ask this next question here, because it's asking about PCB types, but I want to talk about one of the poll questions. Were you surprised at all by I think it was your second poll question, the largest percentage of people are doing PCB through-hole terminals. Were you kind of surprised that surface mount wasn't a bigger emphasis among the audience?
I would say no for surface mount terminals. I'm actually surprised that we do have some usage at surface mount level, and I would like to. I'd like to hear more information about that in the future on what type of surface mount relays are being used. Are these low signal surface mount relays? I should have added another poll question to talk about something like that. But the PCB through hole is what most of these relays, or all of these relays I talked about today, were, and that's what we have seen as the trend. But I like to see that there's other ways we can expand beyond just one termination style.
Interesting. So that kind of sort of leads into the next question: is will Omron release any relays with this safety reading that aren't PCB terminal type?
This again, it depends on the needs. So this is one of the ways that we can identify needs. We see from the polls, we talked about the PCB terminals being the highest answered, surface mount terminals being the lowest answered, but still some interest. But in between both of those, the off-board panel mount and screw terminal, that has seen a lot of responses as well from this poll question. So we have relays with other termination styles in general, and we don't have the expansion yet. But this is where we get the gears turning and start the redesign of existing or the certification ads for products. So I just love to see the information. We don't have it yet. We don't have it on the docket, but we can add it to the docket, and it looks like there are some needs. So I'll keep that in mind.
Yeah, and I think a common refrain here is for the audience: if you have some needs that they haven't addressed, that Zach would love to hear from you.
Yeah, absolutely.
Okay, new question here. This one's from Andre asking, you mentioned that only flux protection doesn't protect against gas. So even if the relay operates with a current lower than 16 amps, if the environment of the relay is exposed to flammable gas, must the relay be sealed?
So this is where we get into that how they rate, how we attain the certification for 16 amp and below switch. We do have unsealed versions, unsealed products that are certified. They are flux protected, unsealed products that are certified as explosion proof. And once they're certified as such, they're no longer an ignition source. And this means that we've done the testing with IEC through IEC to show that we will not ignite based on switching in these flammable gas environments. So even without that full barrier and that full isolation, we will not cause ignition of the flammable gases that were used within. So if there's a particular gas that you're concerned about, we can reference that particular IEC certification. But unsealed is definitely a go as long as we have the testing and the approval by IEC or UL.
Okay, yeah, that's helpful. Our next question here is asking how long until new anti-explosion relays will be released by Omron?
I could say with confidence that we will see that new G6RNE, the 10 amp relay with high dielectric strength within February and very latest early March. So that is a definite. And then the G6QE, the sealed version of that product, which is the 20 to 36 amp switching, expect by mid 2024. And it's also possible that we'll see other expansions to existing Omron series, like I talked about on that list, within like the third or fourth quarter of this year. So be on the lookout and just keep in contact with us, and we'll keep you abreast on what's coming.
Okay. I'm excited to hear the answer to the next question because I can't envision how this works. But do you carry sealed manual switches as well?
So when we're talking sealed manual switches, what I'm thinking about and what we considered those types of switches are like our basic or detection switches or tactile switches. So we do have all varieties of those in sealed versions, sealed models. Some of our basic manual switch families are even IP67 conformed for increased protection against liquids as well. So they do have that sealing, and they can withstand some some liquid or immersion in that way. And we do have a separate product manager for switches and connectors and sensors. So I'd be happy to make that connection if you have needs for sealed switches or any of those products too.
Okay. This question is asking about availability. Are the relays that meet the explosion standards available off the shelf today?
Yes, yeah. So all of the release products, the ones that are already current that I've mentioned, are available through us, through Omron, or through our distributors. The best way to find that certified relay would be that Green Refrigerants webpage, so the Green Projects page on our website. This will give you the list of the base part numbers available with that the base part numbers of the explosion-proof relays. And then if you talk with an Omron representative, we can lock down the full part number with your preferred coil voltage and check on availability through us or through a distributor, whatever your preference is.
Okay. And then this question is asking about where are you manufacturing these relays?
So this is there's a variety. So we have a wide range of parts that are certified. There are multiple locations involved for manufacturing. Our relays are produced in a general sense in Japan, Indonesia, Malaysia, and China. For the existing and newly released explosion-proof relays, they are coming from the Japan, Malaysia, and China factories. And so it will depend on the family selected. So if you have an interest in one or the other, we can let you know where the facility is located.
Okay. Well, that's all the questions we have at the moment. But while we wait to give people a chance to maybe ask them, let's talk about those poll questions more. Zach or Jim, anything interesting you saw as you reviewed the responses from the audience?
Yeah. I saw a few things that one piqued my interest, and two was a great sign. So, firstly, the first poll, and thank you everyone for answering. First of all, we had a lot of responses, and that helps us a lot in understanding if we're hitting the mark for the content and understand where to go for future products. But we have a lot of different industries attending this webinar. It seems like there is that link that we talked about in the webinar between what we're presenting here and the needs from the industries. So it's good to see that. In terms of the protective structures, so having that lower amperage unsealed or sealed versus the higher amperage sealed version, we had a pretty even split there. So that means that there is a need in all categories, and I'm very happy to say that we support all of these categories. So actually, the one that's needed most is 16 amps or above. So maybe our focus should be more on the higher end currents and looking to support some of those bigger power applications like compressors and higher power motors and such. But I think that those are the key takeaways. We talked about some of these polls already, so yeah. Thank you again for answering.
Yeah, I don't know. Did Jim, you want to jump in? Any comment about the polls? Maybe.
I'm just kind of looking at the answers, and as I think Zach pointed out, is really a good distribution of usages. We're seeing heat pump, refrigeration, home appliance, general HVAC, general explosive. So we've got a product for a variety of these applications, and we're going to continue to develop products. As Zach mentioned, the G6Q1A4, which we're going to release in the relatively near future, is going to be a 30 amp relay, fully sealed, so it'll meet that IEC 60079-15. So anybody in there with a kind of a motor pump application, blower motor application, will be able to meet that. And just kind of like as Zach said earlier too, the trending is with heat pumps. We've seen a really high growth of heat pump production in the U.S. relative to what we saw in the past, but that this is really a lot more prevalent in Europe for their style of the way they heat water and things like that. But we're really often as Europe goes, sometimes we follow. That's why the IEC ratings seem to be really leading the pack way more than let's say UL, but then sometimes UL will catch up. And as we do, we'll probably see at some point in time maybe some legislation where using these a little more, they're not highly explosive, they're mildly explosive gases that, are really much better for the environment, though. And I think that's the big push globally. And as we go moving forward, that'll become a bigger issue, I think, here in the North America.
Excellent. Well, we had two more questions come in. We got a few more minutes. Let's just run through these last two here. So this first one is a fun one. Are the non-sealed relays ant-proof? So in India, there were some occurrences where they found ants inside the relay.
That is quite an interesting and regional problem, I'd say. That's external use relays is popular. I mean, you can use them out in outdoor environments in some cases. Mm-hmm. The relays that we have, most of them don't have the holes large enough that I understand that could fit an ant. There might be different ant sizes I'm not aware of, but this hasn't been a problem that I've heard of with Omron relays. Jim, you have a little bit more history with these relays. I'm not sure if you've heard that problem coming up before.
No, I've never heard that in my multiple decades selling into the HVAC appliance marketplace. The biggest problem we normally have is flux getting inside the relay for various reasons, or if you're still in the water wash phase and you're using an unsealed relay, that could create an issue. Typically, we if it's an unsealed relay, we prefer a no wash kind of flux situation. Yeah. But no ants.
No ants. Well, maybe that will be the next IEC certification.
Yeah.
So let's jump to this last question here. When will terminal screw contact panel mounts be released with explosion-proof certification?
So this leads back to why we asked the poll question. These are all PCB relays that we're planning on releasing or already have released with the explosion-proof ratings. I have personally recently heard of the need, and the polls have generated this as well, that there are needs for terminal or screw contactor panel mounts in this sector too. So we're going to work on that, and hopefully we can have a product by the end of this next calendar year or fiscal year, well, calendar year, yeah, or definitely within the next 2 to 3 years if that is becoming more and more of a prevalent need. But no current plan right now that I can speak of.
Gotcha. We had a quick comment come in that said ants are a problem in pool and spa controls as well. So we're all learning something new today.
Definitely.
Before we sign off, Zach, anything last you want to leave with our audience?
I want to thank everyone again for attending and answering the questions, putting questions into the chat. I think this is a great drive to support a trend that is helping the environment globally, and I think we're going to see a lot more traction here. One of the things that I didn't mention when you asked me about the polls is the last poll, or one of the final poll questions we didn't talk about, which is, has your company already made that transition? Now, I'm not sure how many people globally we have here, but locally, I'm seeing that yes, most of the members who answered, or the participants answered, are already making that transition or have made it, or they expect to see it between 1 and 5 years. I have no answers in the no category. So if you're using refrigerants, it looks like you're making this transition. So thank you for stopping by to learn about our portfolio and keep in contact with us and look for new products.
Yeah, thanks. And I want everyone to know that you can download the Zach's presentation slides up in that handout section here. So Zach, Jim, thank you again for that presentation and a great discussion during the Q&A. And thanks to our audience for your participation.
Thank you, Dale.
All right, everyone, just a moment. You'll be redirected to Omron's partner content page on All About Circuits, where you'll be able to view this session on demand and check out other great Omron resources. Thank you all for your time. We look forward to seeing you at another live session again soon.